Hello everyone, I am Aishwarya Lade. In today's video, we are going to learn about optimization technique, and this video is helpful for you to clear all the concept related to optimization technique, and stay with me till the end of the video for understanding concept. Let's get started. What is meant by optimization technique? Optimization is finding the best solution among many. It aims to maximize desirable factors. It also minimizes undesirable ones. This process applied broadly. And optimization technique is a field in mathematics and computer science that deals with finding the best possible solution to problem from a set of available alternatives, and this best solution is typically involve either maximize or minimize. Linear programming based on optimization linear function resource allocation and maximize profit. Linear programming is a mathematical technique used to find the best outcome, that is maximize or minimum in mathematical model whose requirements are represented by linear relationships. Next is resource allocator. Resource allocator imagines a company with a limited raw material, labor hours, and machine time, and linear programming can help decide how to best distribute this limited resource among different products or projects to achieve a specific goal. For example, maximize overall production or profit. Next is maximize profit. For an example, maximize profit gives resource limit and production cost. This provides a concrete and very common example. A business wanted to make as much profit as possible. Then linear programming helps them to figure out ideal production level for various products considered. Next is gradient descent. Gradient descent is a iterative optimization algorithm. This means it does not find the solution in one go, but rather in a series of repeated step or adjustment. Next, linear rate. It adjusts parameter opposite to the gradient. The learning rate determines step size. Next is machine learning. Applications include training machine learning models. It also trains neural network. For example, minimizing cost in line aggression. Next is Newton method. Newton method is to find root finding algorithm and faster conversion. In root finding algorithm, it finds the preliminary root finding functions equal 0 and can also be used for optimization by finding the root of the derivative of the functions. Next is faster conversion. It is generally offer faster conversions than gradient descent when it works, and however it computationally intensive because it requires more calculation and inverting the second derivatives. Next, simulated annealing. In simulated annealing, where we see three types: meta-heuristic approach, escaping local optima, and third is combinatorial problems. In first, meta-heuristic approach. In meta-heuristic approach, it stimulate annealing is a meta-heuristic algorithm. This means it is a high-level general strategy for solving complex optimization problems. Next is accept local optima. A critical feature is probabilistic accept worst solution, unlike greedy algorithm that always move towards improvement. Stimulated annealing can sometimes accept. And third is combinatorial problems. Application include combinatorial optimization. It handles complex landscape. A classic example is the traveling salesman problem. Genetic algorithm. In genetic algorithm, three methods are used: natural selection inspired, second selection and crossover, and third is complex search space. First, natural selection inspired. In natural selection inspired, genetic algorithm are evolutionary and they are inspired by natural selection. Second, selection and crossover. The process involves selection and crossover. Mutation also plays a crucial role, and it works with the populations of candidates. Third, complex search space. In that, application include discrete or complex search spaces. Feature selection in machine learning is an example. Next is constraint satisfaction. Defining object, variable and domain, and constraint propagation. First is defining object. In that, CSP are mathematical problem. They are defined as a set of objects. This object must satisfy specific constraint. Second, variable and domain. In variable and domain, component include variables, domains, and constraint. To find technique involves in backtracking search. Third is constraint propagation. In that, it is also used. Application includes such as scheduling and resource allocation, and Sudoku is a well-known example of constraint satisfaction problem. Next is choosing the right technique. In that, problem type, constraint, and computational cost. It include. First is problem type. It means consider the problem is linear or non-linear. Also continuous versus discrete. Second, constraint. Evaluate the present and natural of constraint. Third, balance accuracy with speed. Consider data availability like gradient and matrix. And it find the best practice in optimization. First is define object clearly. Second, iterate and refine. Third, validate result. This is a conclusion. First is versatile tools, continuous evolution, and key to innovation.